Hey there, Chargers. It's Mrs. Boyd here. Today we're going to talk about factoring using the distributive property. So when we are writing factoring a binomial or a trinomial, it says right here, you're going to look for the greatest common factor, GCF, greatest common factor. So you can rewrite it as GCF, greatest common factor, times the factors. I'm going to show you what I mean. Let's start with 64 minus 40AB. What do these guys have in common? They have, we can divide them both. Their greatest common factor is 8. If I divide 64 by 8, I get 8. Negative 40 divided by 8 is negative 5. And then A and B are going to tag along. We didn't factor those out. And that's the answer. Let's look at the next one. 4D squared and 16. Well, their greatest common factor is 4. I can divide them both by 4. And I've got D squared plus 4 remaining. Next, I've got 15AD plus 30A squared D squared. Well, I know if I look at just the coefficients in front first, I can divide them both by 15. So I'm going to take 15 out front. They both have A. This one has 1A. This one has 2 A's. So that means I can bring 1A out in front. The first term has 1D. The second term has 2 D's. So I can take 1D out. And let's see what I have left. I had 15AD here. I took 15AD out. That means I'm left with just 1 there. 15AD times 1 is 15AD. Then we're going to have the plus there. 30 divided by 15 is 2. A squared, take 1A away. We've got A left. D squared, take a D away, and we've left with a D. So 2AD is what I'm left with there. That's a completely factored binomial. Let's try it again. I've got 32 and 24 as my coefficients. I can divide them both by 8 as my greatest common factor. The first term has A squared. The second one has B squared. I can't take anything out of those. So I'm left with 4A squared plus 3B squared. If I want to check this, I haven't talked about that yet, I'm going to redistribute. So I'll do 8 times 4A is 30, or A squared is 32A squared, and 8 times 3B squared is plus 24B squared. This and this should be the same, and they are. Let's try it again. 30x cubed y plus 35x squared y squared. I can pull out a 5 as my biggest term. I have 3 x's and 2 x's, so that means I can take 2 out. My lowest exponent is what I can remove. 1 y here, 2 y's here. That means I can take y out. So 30 divided by 5 is 6. That's left inside. X cubed, and I took x squared away. It means I only have 1x left. I had y, took it away, no y's. Plus 35 divided by 5 is 7. X squared took it out. Y squared took y out, so I'm just left with y. If I multiply these back together, I should get right back here to 30x cubed y plus 35x squared y squared. Next, looks like we can factor out 15, I think. There's 2 b's and then 1 b, so we can factor 1 b out, and 3 g's. What's left inside? 75 divided by 15 is 5. I have 2 b's. I took 1 away, so I'm left with 1 b. All the g's are gone. Then plus 60 divided by 15 is 4. bg cubed, took them all out. That's it. That's all I got left. 24x plus 36x cubed. I can take 6 out, 12. Just kidding. I'm left with 12x plus 3x cubed. Oh, now look, I made a mistake. I'm glad I did though. Because two things, I multiplied wrong. This should not be 12x, it should be 2x. And I have an x here and an x cubed here. That means I could have taken an x out of my parentheses as well. So let's rewrite again. I've got 12, now I'm going to factor x out. I'm left with 2 plus 3x squared. Now when I multiply, those should be the same. So dot that one. All right, now I've got 3 terms I can factor out from, and what I factor out has to be something I can factor out of all 3 terms. So I can factor 11 out of all of them, and they each have a p. This one's p squared, p to the 4th, p to the 5th. So like I said, whichever one has the smallest exponent, that's what I can factor out. So p squared. Now we do 55 divided by what we factored out, divided by 11 is 5. We have p squared, we took it out, so no p's. Minus 11 divided by 11 is 1. We have p to the 4th, we took 2 away, so we're left with p squared. Yes, that's a 2, don't judge me. And then plus 44 divided by 11 is 4. We had 5 p's, we took 2 away. We're left with 3 p's. Next, we can factor out no coefficients, no integers, because this term on the end has no coefficient, so I can't factor anything out. 1 is only divisible by 1. But I can factor out a y, and we're left with 14y squared minus 28y plus 1. Next, we can factor 8 out and a p and an r. That means we're left with pr minus 3r squared plus 2. Last 3 in this section. I can factor 5 out of all of these and an x. I'm left with 3x squared y squared plus 2xy plus 5. We can factor 3 out and an x. We've got 3ax squared plus 2bx plus 8c. And there's one more. Let's see, 14, 42, and 49 can factor out 7. And 3 t's. T cubed is our lowest exponent. So we're left with 2 minus 6t squared minus 7t. And that's it. We did it. Greatest common factor is the name of the game today, using the reverse of the distributive property. Now, I left you some steps here for when you have 4 terms in your polynomial. It says mentally separate the first 2 terms from the second 2 terms. We're not going to do it mentally. We're going to really make parentheses around these guys. I want you to make note here. I included the sign on the 3rd term in my second parentheses. This is important in case it's a negative. And then we factor each greatest common factor separately. So let me, here we go. Let's do these in some different colors so we can see the difference. So I've got x squared plus 4x to factor out of. I can only factor x out. And we're left with x plus 4. Then I've got 2x plus 8. Well, I can factor plus 2 out. And I'm left with x plus 4. Note, this and this are the same. Call them twins here. I've got a twin pair of parentheses. So Everything is factored as much as it can be, and I've got twin parentheses, which is exactly what I want. My final factored form, I'm going to reverse this. I'm going to put the twin in front, x plus 4, and then everything not inside of parentheses is going to go together in one set of parentheses, x plus 2. And that's it. Let's try it again. I'm going to factor these guys together and the last two together. We factor out what we can. I can factor a out of the first set, and I've got 2a plus 3. I can factor plus 3 out of the second set and have 2a plus 3. Twins, exactly what we wanted. So we put 2a plus 3, our twin, and then everything not in parentheses, a plus 3. Let's keep it going. First 2, second 2. We can factor out 4b, and we're left with b minus 3. Second set, I can factor out plus 2, and I'm left with b minus 3. Put it all together. Twin, b minus 3. Everything else, 4b plus 2. So when I multiply these back together with the FOIL method or with however you best multiply polynomials, it should get us back to our original that we had. Let's do a few more like this. All right, first 2, last 2. I can factor out 2x, and we're left with 3y minus 4. I can factor out of this one plus 5, and we're left with 3y minus 4. Put it all together, and I've got the twin, 3y minus 4, and everything outside, 2x plus 5. Having two variables is completely okay. First 2, second 2. All right, we can factor out 2m, and we're left with negative 3p plus 2. And then we can oh Lord, we can factor out 6, and are left with 3p minus 2. Got a bit of a problem now. I've got negative 3p, positive 3p, plus 2, minus 2. What I do to remedy this is factor a negative out of one of my parentheses. I'm going to choose to factor it out of the first one. So I'm going to take this negative and treat it like a negative 1. That makes my first term negative 2m. And that means all the signs in the parentheses change. 3p minus 2. Second parentheses doesn't change at all. And now we have these twins that we need. We write our final factored form, the twin, 3p minus 2, everything not 2m plus 6, negative 2m plus 6. Well, I've got one more thing we can do that I didn't see until just now. I love it when I make mistakes. I'm going to scoot it up so I've got some more space. Here, negative 2m plus 6, I can factor a 2 out of that, or a negative 2. So let's do that. Now I'm going to write it. I'm going to factor negative 2 out of here. So we'll have negative 2 out in front. And that'll make that m minus 3. And then 3p minus 2. I just flip-flopped these guys around, and that's totally okay. So if you can still factor something out, you should do that. Look, I made the same mistake up here. Let's fix this one too. We can factor 2 out of this term. So we'll factor 2 out. We're left with 2b plus 1 and b minus 3. Whew. Let's see if I can go one problem without making a mistake. No guarantees. Teachers are human too, people. All right. First set and second set. I can factor out 3a, and we're left with 4a minus 5b. And then I can factor out, well, I can tell something ahead of time. My first term here is positive. This first term is negative. I know I'm going to have to factor a negative out. So let's just do that. Negative 4 that we'll factor out. And we're left with 4a minus 5b. We can put it together. Everything not in parentheses first. 3a minus 4. And our twin, 4a minus 5b. I think I did it the other way before, but really it doesn't matter. It's the same answer no matter which way you write the parentheses down. All right, that's a lot. I know it is. Let's keep it going. Flip your paper over. Now we're going to solve. To solve a polynomial equation, set the equation equal to 0, exactly like this one has been done to. Factor the polynomial, already factored. Set each factor equal to 0 and solve. So we have factored this lovely quadratic equation. X plus 2 times x minus 2 are our factors. We want to know what x is equal to. I set each of these lovely parentheses equal to 0. And then I solve. Subtract 2. I'm left with x equals negative 2. Add 2. And I'm left with x equals 2. And that's our answers. When we write the answers down, we separate them with a comma. 2, negative 2, 2. And that's it. Let's try it again. First set, that should be a plus, equals 0. Second set equals 0. And then we solve. Subtract 6 for 1, and we're left with x equals negative 6. Add, don't know what I did that for. Add 15 to each side. And we're left with 3x is 15. Divide by 3, and that's x is 5. So our final solution, x equals negative 6 and 5. Let's do some more. First set equal to 0. Second set equal to 0. And we solve. Subtract 1. 2x is equal to negative 1. Divide by 2. Maybe, if your computer works, there we go. And we've got x is negative 1/2. Add 1. 2x is 1. Divide by 2, that means x is positive 1/2. So our two solutions, x is negative 1/2 and positive 1/2. Now, one little bonus extra step, we'll have to factor first. I know I can factor 6 out, and I know I can factor p out. So I'm left with p plus 3 equals 0. I set my first term equal to 0. And I set the second term equal to 0, which is p plus 3. And then we solve. Subtract 3. I've got p is negative 3. Or divide by 6. I get p is 0. So our solutions, p is 0 and negative 3. Let's do it again. You can factor out 3 and an m. And we're left with 8m minus 5 is 0. We set these equal to 0. 3m is 0, and 8m minus 5 is as well. Divide, and m is still 0. We add 5, and get 8m is 5, and divide. and m is 5/8. So final answer, m is 0 and 5/8. Let's factor again. I know I'm going to flip this around and make it 14k squared minus 7k is 0 because that's really screws me up. So I'm going to factor out 7, and that should be a k and a k. I'm left with 2k minus 1 is 0. I set each of those parts equal to 0 and solve. Divide by 7. That's a k, I promise, is 0. Add 1. 2k is 1. Divide by 2. And k is 1/2. So k is 0 and 1/2. Just a few more. I'm going to get everything to the same side of the equation. So that means I'm going to subtract 5y from each side. And we'll have 10y squared minus 5y is 0. Now we can factor. I'm going to factor out 5 and y. And I'm left with 2y minus 1 is 0. Set each part equal to 0. Divide. That means y is 0. This is looking familiar. It means 2y is 1. Let me move my work up here. It means y is 1/2. So y is 0 and 1/2. Same idea. We're going to get everything to the same side. I'm going to flip it around too, so don't be too confused. 12y squared minus 4y is 0. What can I factor out? I can factor a 4 out and a y. And I'm left with 3y minus 1 is 0. Set them equal to 0. Oh, that should be a 4. I get y is 0. Add 1. 3y is 1. Divide by 3, and y is 1/3. So y is 0 and 1/3. Oh my gosh, it's the last one. I can't even believe it. We'll subtract 9y and get everything on the same side. 15y squared minus 9y is 0. I can factor out 3 and y. Left with 5y minus 3, and that equals 0. Each part's got to equal 0. And then we solve each equation. Plus 3 this time. 5y is 3. And then divide, and y is 3/5. So y can equal either 0 or 3/5. Whew, that was a lot. Thanks for hanging in there, guys. Hope you followed along as best you could. If you have any questions, you totally know where to find me.